We are in Module 7. This week we will continue to talk about polymorphism. We will finish Chapter 11. Chapter 11 we talk about inheritance and polymorphism. Last week we introduced inheritance relationship. We have is a relationship. So for all the child class inherited from the superclass, they are one kind of superclass object. So that brings us the polymorphism. So to discover polymorphism, actually we want to talk about is through the inheritance relationship, the child class is not only a type of the child class object, they are also is a parent class object. So then we talk about the overriding method. For any method you want to better fit the child class, you can override the method. So this one brings us the dynamic binding. And also because we have the is relationship, sometimes we need to do the downcasting, sometimes we need to do the upcasting. So then we will introduce about that. So afterward, we will introduce 3 different ways to compare objects. We talk about equals operator, we talk about equals, then continue we talk about comparative method. So that's what we'll talk about in this week. And after this week, we have one more module before the midterm exam. So the midterm exam will cover from module 1 to 8. This week we are in module 7. We finish chapter 11. Next week, we will go to chapter 13. We talk about the abstract class and interfaces. So then all the module 1 to 8 will be in the midterm exam. Midterm exam is always happen on Monday in week 9. So I will remind you how you will take the midterm exam next week. So the first thing that's introduced, polymorphism. Polymorphism you can see from the English. Poly means you have multiple forms. So polymorphism means that a variable of supertype can refer to a subtype object. The reason is, remember, all the subclass, they are one kind of superclass object. So that's why sometimes when we want to include all different kind of shape, remember last week we talked about we have geometric object. So geometric object is the superclass from the circle class and also from the rectangle class we have last week. But sometimes just continue. How about we have a triangle, we have a square, we have all different kind of geometric object. So when I want to collect all the geometric object together, so when I say the geometric object, I'm specific say I have multiple circle object, I have multiple triangle object, I have several square object, I have several rectangle object. So when we want to put them together in an array, but our array type we need to specify, right? Right, so it's difficult. Should I take the circle as a type or rectangle as type? Then don't worry about that because no matter circle, rectangle, triangle, or square, they are all one kind of geometric object. So that's why here, in order to collect all different kind of shape type, we can just create an array as a geometric object. So then we can contain all different kind of shape object. So that's a polymorphism mean. That we can using a variable of supertype can refer to a subtype. So here the supertype mean the superclass type. A type defined by the superclass we call supertype. For example, geometric object is the supertype. So the subtype, that's a type defined by the subclass. So for example, circle is a subtype. So that's the definition and the meaning for the polymorphism. So that's here continue with earlier I explained to you. The inheritance relationship actually bring the polymorphism because they enables a subclass to inherit all the features from the superclass, and they can add a new feature. A subclass is the specialization of a superclass. So every instance of a subclass, that's me, any object of a subclass is also an instance, the object of the superclass. So that's earlier we give you the example. You see, circle is a geometric object. Triangle is a geometric object. Rectangle is a geometric object. So that's why we can always pass an instance of a subclass to a parameter of the supertype. So remember what we mean here is the superclass type, that's me. In Java, we always has what? We always have the object reference name. So before we do this way, we do circle C1 equal to new circle. Right? So that's how we can specify maybe the radius equal to 5. So we can using a circle variable to refer to my circle object. But here now, if I try to define a geometric object variable, so we say that's the G obj. So this object variable, remember this one is only object variable. For C1 or for the obj, they are only variable. But here actually, C1 can refer to a circle, but now obj can refer to C1 or not? Yes, you can. Yeah, because child class object is one kind of superclass object. So this one can help us that we will have the polymorphism example, including a static method we call display object. So I want to display the shape object information. For example, you're passing me an object, then I want to display their area and their parameter information, right? So one thing is right. So when I display this object information, can I pass in a circle to get the parameter and area? I can. Can I pass a rectangle object? I can get the area for the rectangle and the parameter. I can, right? So do you want to write two separate methods for triangle, for circle or rectangle? No, we don't need, right? Because one thing is no matter circle, rectangle, or triangle, they are all one kind of geometric object. That's why this static void method, you only need to define the object we pass, the data type is geometric object. So then when you implement that, we can using this object reference to display the area information. Right, we just need to call the get area. Then we just need to call the get parameter. We can get that. So after we have this method, we can invoke this method but pass a circle or rectangle object to display the information. Why? Yeah, here is question mark. Yeah, of course you know that's true because circle or rectangle, they both are geometric object. So that's why we see the example here. So this example, we just have the polymorphism demo. So then here is our display object method. So then you see here, after I pass in the object, right? Okay, so I can get, so this one, because remember, when we are in geometric object, we don't have the get area method yet. But here we just display the get day created and the get color. Because these two is we define in the geometric object. So then, right, can I do that? I can. So because one thing is these two method is defined in the geometric object. So then when we call that, we can get the date created, we can get the color. So then in this static method, so the main function you see, when I call display object, but here I create is what? I create a circle object. But that's fine because circle object I can be referenced by the geometric object variable. So even I pass the rectangle, then fine because geometric object, this object reference can refer to a rectangle object. So that's why we have the output. Okay, so make sure you will try to run this program on Eclipse. Make sure you will run this program on the Eclipse. So please make sure, remember I gave you all the file from in the demo file on Canvas. So that's why when you try to run, you need to make sure you download all the file I show you under the demo file module 7. Because one thing is we run the polymorphism demo, but we call circle, we call rectangle, we call geometric object class. So that's why here you will see they all need to be Java circle.java file, geometric object.java file, rectangle.java file. They need to be in the same place. So that's why now you see we can run. So you can run this program. Then we get the result. Because the console output is on the side, so that's why I need to show you. So make sure you download everything and try and see if you have any question. So we can see here because your object is geometric object. So that's why when they invoke the method, they only can invoke get date created and get color. So then if we do that, so then they just display the date information and the color information. So we need to remember, here we're using the parent class type. So all the method can be invoked. There has to be defined in your parent class method. So that's why before when we are in the geometric object, so you see this one is actually is from last week, our geometric object. So then we have get color, we have get is filled, and we have the get date created. So that's why you see here, or we also have the toString method, right? So this toString method actually show you the date created and the color. So how about we invoke this toString method? So that's why instead of we just invoke each method, how about we just display? You can just call system.out .print ln, right? So here, how about we just call the toString method? Remember, toString method, you can either invoke the toString method or you just using the object variable name in the print. So then they will just invoke the toString method. So we see here, we run the program. Okay, so that's why they were using the same one we have. You see, they have they will call the toString method, right? But then I want to show you that this toString method, when they display the same thing we have. So you see here, if you run that, they will say created on the date, then color, then fill, then they say radius. Okay, or you see in the rectangle, they also show the width and the length. But one thing is, if you go back to the geometric object, this toString method will only show what? Will only show you the color, the date, color, and the field information. So why they also show the rectangle circle information? The reason is because we overwrite In the rectangle class, we override the toString method.